In this section we will study LTE interfaces and control end-user plane protocol stack. After completing this section, you will be able to define the key LTE interfaces, explain the LTE interworking and mobility with 3GPP and GSM GPRS, describe the protocol structure over S1MME, S1U, X2C and X2U interfaces, explains LTE control end-user plane protocol, explain the non-access Stratum protocol functionality. LTE network components work together to deliver end-to-end high-speed packet data services. LTE has defined interfaces that enable communication between various network elements in the LTE architecture. We shall be discussing various interfaces in detail as per this course. Brief summary of key interfaces is LTE-U. This reference point is located between UE and EATRN. OFDMA-based air interface protocol is used across this interface. S1MME. This reference point for control plane protocol is found between ENB and MME. All signaling is carried over this interface. S1U. This reference point for user plane protocol is found between ENB and SGW. This interface supports bare user plane tunneling and inter-ENB path switching during handover. S5. This reference point is found between SGW and PGW. This interface is used to move traffic between two gateways. S11. This reference point is found between MME and SGW. All control information between these two nodes is carried over this interface. EPS also supports interworking and mobility, handover, with networks using other radio access technologies, RATs, notably Global System for Mobile Communications, GSM, UMTS, CDMA 2000 and WiMAX. The architecture for interworking with 2G and 3G GPRS UMTS networks is shown in the figure. Two new interfaces, S3 and S4, are added. S3 is the reference point between SGSN and MME. The interface carries mobility handover signaling between 2G/3G and LTE systems. S4 is the reference point between SGSN and SGW. It is the user plane counterpart for S3 interface. It enables user and bearer information exchange for inter-3GPP access system mobility. The SGW acts as the mobility anchor for interworking with other 3GPP technologies such as GSM and UMTS. SGW also supports direct tunnel via S12 interface for 3G. The S1 interface connects the E node B to the EPC. It is split into two interfaces, one for the control plane and the other for the user plane. The protocol structure over S1 is based on a full IP transport stack with no dependency on legacy SS7 network configuration as used in GSM or UMTS networks. S1MME uses Stream Control Transmission Protocol Stack or SCTP to transfer several independent streams of messages in parallel over IP and provides reliable delivery of the signaling messages. S1 Application Protocol, also called S1AP, sits on top of SCTP. It is responsible for bearer connection establishment procedure, handover signaling procedure, paging procedure and non-access Stratum or NAS transport procedure. LTE has also built flexibility into the lower layer protocols, giving the operator full flexibility regarding the choice of IP version and the data link layer. For example, this enables the operator to start deployment using IP version 4 with the data link tailored to the network deployment scenario. S1U interface supports the transfer of user traffic. S1 user plane protocol structure is based on the GPRS user plane tunneling protocol, also called GTPU, which is also used in UMTS networks. GTPU, in turn, uses UDP over IP to transport the traffic. The IP version number and the data link layer have been left fully optional, as for the control plane stack. The X2 interface is used to interconnect eNode B. Like S1 interface, X2 interface is also split into two interfaces, one for the control plane and the other for the user plane. The control plane protocol stacks over the X2 interface is the same as that for the S1 interface, with the exception that X2 AP is substituted for S1 AP. This also reaffirms that the choice of the IP version and the data link layer are fully optional. This is a new protocol introduced in LTE and does not have any equivalent protocol in UMTS, although it has some commonality with RNSAP, which runs between two adjacent RNC and UMTS. The X2AP protocol is responsible for mobility management, load management and general X2 management and error handling functions. X2U interface supports the transfer of user traffic. It is same as S1 user plane protocol interface. X2 user plane protocol tunnels end user packets between the eNode BS. The X2U interface provides non-guaranteed delivery of user plane PDU between eNode B. Let us now examine LTE Control Protocol Stack. Physical layer on the UU interface supports following main functions: error detection on transport channel, support for hybrid ARQ, hybrid automated repeat request, power weighting, physical channel modulation, demodulation and link adaptation, frequency and time synchronization, physical layer mapping, support for handover, support for multi-stream transmission and reception, MIMO. Layer 2 is split into the following sublayers: Medium Access Controller MAC, Radio Link Controller RLC, Packet Data Convergence Protocol or PDCP. MAC is responsible for dynamically managing error interface resources among various UEs. The MAC layer achieves this via managing logical resources called logical channels, depending upon what type of data is transferred, and transport channels, depending upon how and with which type of characteristics the data is transferred. RLC is responsible for segmentation and reassembly as well as the error correction procedure, through automated repeat request or ARQ. An RLC entity can be configured to perform data transfer in one of the following three modes: transparent mode or TM, where the RLC acts as a pass-through layer for the data; unacknowledged mode or UM, where the RLC executes all the functions except for storing and retransmission of data; and acknowledged mode or AM, where the RLC implements its full functionality. PDCP provides data transfer, header compression of IP data flows using the robust header compression or ROHC algorithm, and ciphering services to both control plane, RRC and user plane, application, entities. PDCP provides protection and verification services to control plane protocols. RRC is the main controlling function in the access stratum or AS. The RRC layer provides the EUTRA and radio signaling connections to the upper layers, for example, Radio Resource Manager, RRM, to support the exchange of the upper layer's information flow. The signaling connection is used between the UE and the core network to transfer upper layer information. For each core network domain, at most one signaling connection may exist at any given time. The RRC layer maps the signaling connections for one UE on a single RRC connection. In EPS, non-access stratum or NAS procedures include the procedures used by the protocols for mobility management and session management between user equipment, UE, and MME. There are two NAS protocols that uses the services of lower layers, EPS Session Management, ESM, and EPS Mobility Management, M. The ESM protocol provides procedures for the handling of EPS bearer contexts. Together with the bearer control provided by the access stratum, this protocol is used for the control of user plane bearers. Network-initiated procedures supported by this layer are to create, activate, modify, and delete EPS bearers. UE-initiated procedures supported by this layer are to request to create, modify, and release EPS bearers with specific OS. If accepted by the network, a corresponding network-initiated procedure is started. The equivalent protocol in UMTS is Session Management, SM. The IM protocol provides procedures for managing mobility when the UE is using the eLearning. The IM protocol also provides control of security for the NAS protocols. IM procedures can be divided into three groups. 1. IM common procedures used for both connection management and mobility management. These procedures are always network initiated. 2. IM-specific procedures used only for mobility management. All procedures under this category except attach are initiated by UE. Detach can be initiated by both network and UE. 3. IM connection management procedures used only for connection management. Paging procedure is initiated by network while the service request procedure is initiated by UE. We will discuss some of these procedures in more detail later in this module. This completes the module. Click Next Topic from Navigation menu.